Thermo Scientific Magic is a dual-mode ion source, enabling depth profiling analysis and surface cleaning of both soft and hard materials on the same XPS instrument. Magic is completely controlled from Avantage, the surface analysis software used on all Thermo Scientific XPS systems. The gas handling and source control are completely invisible to operators. All they need do is choose the mode they wish to use, either a monatomic or cluster ion beam of a particular energy, and run the experiment. The first stage in the process is to generate a beam of gas clusters. This is done by a supersonic gas expansion, which forms a jet of gas but also rapidly cools it, causing atoms to coalesce and form clusters of various sizes. The supersonic expansion is created by introducing gas at a relatively high pressure, typically a few bar, and expanding it into a region at low vacuum through a nozzle. The shape and diameter of the nozzle and the pressure drop across the nozzle are the crucial factors in determining the success of cluster formation. The supersonic expansion will eventually collapse under the effect of shock waves. To prevent this, the beam is extracted through a shaped skimmer, which maintains the expansion and prevents excess gas from progressing through the source. The beam passes through the first skimmer into a second differentially pumped region, then through a second skimmer and into the main body of the source. The beam of gas now needs to be ionized. This is done by bombarding the gas clusters with electrons generated from a hot filament. This creates a beam of ionized gas clusters which can now be manipulated by electrodes in the source. The first set of electrodes extracts the beam and then directs it onto the entrance of the mass selection region. The cluster beam now needs to be filtered so that only clusters of the requested size and charge are used to etch the sample. This is done by using a magnetic field to deflect the beam around the bend in this section of the source. Only clusters of the correct size and charge will make it to the exit of this section. The rest of the beam strikes the internal walls and is lost. The final stage for the beam is to use further electrodes to create the raster so that the beam is scanned across the sample, ensuring that data is collected from the bottom of the etch crater and to focus the beam into as small a spot as possible. Note that the focal point of the beam should be at the sample surface. The beam is usually rastered over an area of a few millimeters squared. In monatomic mode, the gas is introduced directly into the ionization region. Again, the gas is bombarded with electrons to create ions with a positive charge. The ion beam is then extracted and focused onto the mass selection region. In monatomic mode, the magnetic field is not applied, as there is no need for any mass selection. The bend in this section of the source does help to suppress any neutral atoms that are traveling through the source and prevents them reaching the sample. The ion beam is then focused onto the sample and rastered across the surface using the electrodes in the front of the source. The monatomic ion source can generate beams with a range of energies and beam currents to profile through both thick and thin layers. With both cluster and monatomic ion beams available from a single source, Magic is the best choice for investigating samples made from a mixture of materials. Use the cluster beam to profile the polymer components, and use the monatomic beam to profile the inorganic components. Magic, only available on Thermo Scientific surface analysis instruments.